Hello students. So today we are going to solve two more typical examples on the centroid of areas. So let us note down this example. If ABC represents sector of a circle, locate the centroid of shaded portion with reference to the given x and y axis. Here what is the shaded portion? The green portion. So ABC is the total sector from which we are removing the triangle and a circle. So the remaining portion is the shaded portion, right? So this is the given figure. Now I will divide the given figure into three parts. So part 1 is the sector of a circle. 2, triangle. I will say sector ABC and the triangle ADE, and the third figure is circle. So let us say circle F, right? So now let us find out. Now A1 x1 y1, A2 x2 y2, A3 x3 y3 with reference to the given x and y axis. Now when you calculate A1, it is area of the sector. Area of the sector is given by, what is the formula? Alpha r square, whereas alpha is in radians. So now first let us calculate what is alpha. So the total angle subtended by the sector with respect to the center is 2 alpha. So half of that is alpha, right? Now from the right angle triangle AOB, from the right angle triangle AOB, we can write tan alpha is equal to opposite side, that is OB given as 60, upon adjacent side AO, that is 90. So it is 60 upon 90. So you can calculate it alpha as 33.7 degrees, right? So if you want to convert this into radians, into pi by 180, because in the formula we need alpha in radians. So it is 0.588. Now R. What is R? Radius of this sector. That radius is nothing but either AB or AC. Now from the same right angle triangle AOB, using Pythagoras theorem, you can calculate AB, that is nothing but R, is equal to square root of 60 square plus 90 square. That is the radius of the sector. So this is 108.17 millimeters, right? Now A1 is equal to alpha in radians 0.588 into R square, 108.17 whole square. So this gives you 6879.6. 6879.6 mm square. right? Now x1, see this given figure, the entire figure is, the given figure or lamina is symmetrical. About y-axis. Therefore, straight away we can say that x bar is equal to 0. So now only we have to find out y bar. So y bar is given by summation ay upon summation a. So that is a1 y1 minus a2 y2 minus a3 y3 upon a1 minus a2 minus a3. Why this minus a2 minus a3? Because 2 is the triangle and 3 is the circle. So these portions are removed. Therefore, we are taking minus. Now we have got a1 as 6879.6. Now to calculate y1. So what is y1? It is the distance of centroid of this sector from x-axis. So we are having formula that this sector is symmetrical about this y-axis. Centroid will be located on the symmetrical axis for this sector, and the distance of centroid of the sector from center of the circle, as per the formula, it is 2r sine alpha, which is in degrees, upon 3 alpha. Alpha is in radians. Am I right? So this is the distance of centroid of this sector from the center. But here y1 means what? Distance of centroid of the sector from x-axis. So this is our y1. Am I right? So you can say y1 is equal to, so this total it is given 90 A2O. So it is 90 minus 2r sine alpha upon 3 alpha. So that is equal to 90 minus 2 into, what is the r radius of the sector? It is 108.17. 108.17 into sine alpha, alpha is in degrees, that is 33.7 upon 3 alpha, alpha is in radians, 0.588. So solving this, you get y1 as 21.95. 21.95 millimeters. Is it clear? So now we have got a1, y1. Now a2. What is a2? Area of this triangle ADE. So triangle ADE, area is equal to half into base into height. Base is DE. So you will find that DE as 40 into height is 30. So how you have got this 40 DE? For example, let us say this is A up to this point. From OG is A. From the right angle triangle AGO. So we have tan alpha is equal to, so putting alpha as 33.7. Now you will get A as 20 millimeters. So the base of the triangle DE is 20 into 2, that is 40. Right? So this will be 600 mm square. Now y2. What is y2? Distance of centroid of this triangle from x-axis. So we know the distance of centroid of the triangle from base of the triangle is given by 1/3 of its height. But we want to measure from x-axis. So it is 60 plus 1/3 of 30, 60 plus 10, 70 millimeters. Right. Now A3. A3 is the area of the circle pi r square. What is the r? Radius is given 10 millimeters. So it is pi into 10 square. So that is 314.16. Now y3. Y3 is distance of centroid of the circle from x-axis. So center of the circle is the centroid. It is given as 30. So it is 30 millimeters. Now putting all the values over here. A1 68 79.6 into y1 21.95 minus A2 600 into y2 70 minus A3 314.16 into 30 divided by A1 68 79.6 minus A2 minus A3 314.16. So solving this, you will get, so y bar is equal to 16.71 millimeters, whereas x bar is 0. So this is our answer. Understood? So we'll go to the next problem. Locate the centroid of the plane area as shown with respect to the origin O. So centroid of the plane area with respect to the origin O. What is the plane area here? The area which is in blue, right? So you can consider here, you can divide this figure into two parts. So we have to locate the centroid of this shaded area, right? So the one is quarter circle, of radius 120 millimeters, right? And second one is semicircle of radius. What is the radius of the semicircle? Here diameter is 120. So radius is 60. So we are dividing this into two figures. Now you can have first A1, area of the quarter circle, pi r square by 4. Then x1, distance of centroid of the quarter circle from y-axis as per the formula 4r by 3 pi. Similarly, y1, that is centroid of the quarter circle from x-axis. It is again 4r by 3 pi. A2, area of the semicircle, pi r square, r is 60 divided by 2, and x2, this circle is symmetrical about horizontal axis. Centroid will be located on the symmetrical axis. Its distance from the base of the semicircle as per the formula it is 4r by 3 pi, nothing but our x2. So it is 4r by 3 pi. Now what is y2? Distance of centroid of the semicircle from x-axis. So this distance, that is y2. nothing but 60. Now do the calculations here. So we have A1 11309.73 mm square. X1 is 50.93 millimeters. Y1 is 60. Sorry, Y1 is again same. So it is 50.93. A2 5654.86. X2 here 4r by 3 pi 25.46, and Y2 as 60. Now you have X bar is equal to summation AX upon summation A, that is A1 X1 minus A2 X2 upon A1 minus A2. So putting all these values, 11309.73 into 50.93 minus 5654.86 into 25.46 divided by 11309.73 minus 5654.86. So solving this, you will get X bar as 76.4 millimeters. Now Y bar, summation AY upon summation A, that is A1 Y1 minus A2 Y2 upon A1 minus A2. So 11309.73 into 50.93 minus 5654.86 into Y2 is 60 divided by 11309.73 minus 5654.86. Solving this, you are going to get 41.86 millimeters. So you have X bar and Y bar. Understood? So these are our answers. So with this, we have completed the topic centroid. See you in the next topic, that is moment of inertia. Thank you.